Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the humidity of atmospheric air. The amount of water vapor in the air can be specified in various ways. Probably, the most logical way is to specify directly the mass of water vapor presented in a unit mass of dry air. This is called absolute or specific humidity and is denoted by omega or D. The specific humidity can also be expressed as, where P is the total pressure. Consider 1 kilogram of dry air. By definition, dry air contains no water vapor, and thus its specific humidity is 0. Now, let's add some water vapor to this dry air. The specific humidity will increase, and small vapor or moisture is added. The specific humidity will keep increasing until the air can hold no more moisture. At this point, the air is said to be saturated with moisture, and it is called saturated air. Any moisture introduced into saturated air will condense. The amount of water vapor in saturated air at a specified temperature and pressure can be determined from equation 725 by replacing PV with PSV, the saturation pressure of water at that temperature. The amount of moisture in air has a definite effect on how comfortable we feel in an environment. However, the comfortable level depends more on the amount of moisture the air holds relative to the maximum amount of moisture the air can hold at the same temperature. The ratio of these two quantities is called the relative humidity. There are 3 ways for the atmospheric air from unsaturated to saturated. The first way is by constant temperature humidification as shown by the process of A to B. The second way is by adiabatic humidification as shown by the process of A to C. The third way is by cooling under constant pressure as shown by the process of A to D. In the figure, Tc is the adiabatic saturation temperature. Td is the dew point temperature. The ordinary temperature of atmospheric air, Ta, is frequently referred to as the dry bulb temperature to differentiate it from other forms of temperatures that shall be discussed. The relative humidity ranges from 0 for dry air to 1 for saturated air. Note that the amount of moisture air can hold depends on its temperature. Therefore, the relative humidity of air changes with temperature, even when its specific humidity remains constant. Relative humidity indicates how far the wet air leaves the saturated air, also called saturation. Based on the relative humidity, the absolute humidity can be expressed as, and then we can also express the relative humidity as. Okay, that's all for this task. Thank you very much, and see you next time.